reading the same files 10 times, but if that file's 1 gig, the working set of that file is 1 gig even if you read it 10 times. So it's how much memory would you need to keep everything in memory. And I spent a fair amount of time writing some dtrace code. So if this is something that you think, oh, I need to know what the working set is, I have some dtrace that does this. It's actually C written around dtrace. And it's not trivial. But I'd love to get some real world exposure. So do get in contact if that's one of your problems. But it was really interesting how, in this case, the particular customer was not open to a solution that cost a fraction because it wasn't their company policy. I lost no sleep. Right. So, I think it's fashionable in the technical community not to know what governance means, at least not to admit it. And so, where I first came across the word governance in any anger was I was mentoring a colleague of mine in a different part of the organisation, who's moved on now, a gentleman called Wayne Hawken, mentoring through a peer-reviewed promotion, and it was great because I learnt a great deal. So I kind of work on the operating system side, and Wayne worked at a kind of more conceptual level. And I'd been working with a customer who's had an outage, and trying to root cause the outage, and the outage came down to set max throttle equals 20 was missing from etc. system. It was a service outage, not a machine outage. And so that value will say how many IOs you can submit to a particular LUN at one time. And it caused some really serious performance issues during acceptance testing, something that was quite major, and a rollout was delayed. And I just thought of it as a technical problem. But Wayne, we were talking about this particular issue, and Wayne says, oh, it's a governance issue. And the group who decided who did the build were not the group who knew what should go into the build. So within the customer, there were people who absolutely knew that this setting should be in there for that configuration. But they were not asked for input. And so who decided what went in wasn't really in some of the overall best interests. And that's kind of what governance is about. And it's not I apologise if it's not technical, but this is one of the, often the wrong people are making the decisions. And it's really quite fun in a meeting. So you feel you're really surfing on the edge when you say, oh, we've got a governance problem. What do you mean? And you know what I know about governance is what I've read in Wikipedia. And you really feel you're surfing on the edge, trying to bluff your way through. But it's really good with, if you can just get that little bit of knowledge about what governance means, people will back off. And you'll kind of get your technical recommendations through. Okay, a little bit more, probably a little bit more of what you came for. I'm standing in your way. Should I stand over here and block these people's view? Okay. So ZFS is wonderful. I'm sure you all know that. A couple of things that, in most cases, when we design something like ZFS, it's a general case. The defaults are set up for the general case. So if you're doing something specific, like running Oracle, then there are sometimes good practice. Don't stand there. I have no idea where I should be standing. Most of the time, setting ZFS arc max is the right thing to do. And so ZFS has a philosophy of let us grab, like most file systems, let's grab as much memory as we can. And if the operating system wants it back, we'll give it back. And this can sometimes make contention situations where you have processes that are wanting 4 megabyte large pages, like 4 megabytes pages, and file systems will typically want smaller pages. So you can have pages being broken down and coalesced. So to avoid that, it can be a good idea to set ZFS argmax. And particularly with Oracle, we've got a large SGA. What's the right value? Depends on what you're doing. But most of the time, it's one of those things I think you'll only get by observation and kind of a guess and then observe. Another ZFSism, and these are the things that we see aren't done, is not matching the record size to block size. So if you're running an Oracle database and you've got the record size of 128K, which is the default, well worth resetting that for table spaces to 8K, if that's the Oracle block size you use. Let's try standing here and see if we make any noise. Well, this is less common now than it used to be, but sort of 2 or 3 years ago, it was kind of ZFS performance analysis was a bit like shooting fish in a barrel. You'd look and say, oh, well, what's your disk layout? And the customer base seems to say, oh, okay. But very often there'd be small random write intensive workloads put on RAID Z, which really doesn't suit that workload. So when you have RAID Z, effectively the number of IOPS for small random writes, even you may have 10 disks in that stripe, same with RAID 5, your IOPS are limited to the speed of 1 disk. So unless you're doing large sequential I/O, or you don't care about performance, then staying away from RAID Z 1, 2, 3 is a good idea. Another common gotcha, and it has got a lot better. It used to be about 63%, but it's how full you could run a well-used ZFS file system. And it's getting better. It's better in 11 than it's in 10, and will continue to push forward. But all file systems will suffer if the file system is full, from a performance point of view, because it has to go around searching for blocks and then trying to coalesce them. And ZFS with its copy on write maybe suffers a little bit more. So that's a common one. Another point of understanding that often isn't there, and is what's behind a performance issue, is that many customers don't understand where something like a database which has synchronous write semantics, and that's where the intent log comes in. So you write immediately to the intent log, and in the event of failure, that intent log can be replayed, and at some point in the next 5 seconds, ZFS will write out in its own order the data. But for synchronous writes, really the speed that you get to that intent log is key, and being able to put that on a separate disk that's not used by anything else, that there's no contention. Maybe if you really care about putting it on solid state, there's little benefit putting an intent log on a contended disk on the same volume as as the rest of, say, a table space, and thinking that it won't, just separating it out won't help. It has to be on its own fast storage that is contended if you really want to get good performance. And often come situations where there's no understanding of whether the workload is synchronous or asynchronous, the I/O size, maybe there are multiple I/O sizes, and whether the I/O is random versus synchronous. And these are sort of, for me, going in trying to understand the landscape of a performance issue, then these are quite fundamental. Okay. So, how many people have friends who don't know how to interpret IO-stat columns? Friends, yeah, okay. Right, this is good. Right, now we're getting there. Okay, so we will dispense with the hand wavy rubbish, and let's get down to it. Okay. So, who's over here? No. So the percent. Let's start at this side. So this is just an IO stat. I will admit that I've doctored some of these figures. Okay, I've made them up, made up some of them. But this is an I/O stat. Those are my favourite flags. Pick your own. XNZM. So this column here is the number of reads per second. This column here, the number of writes per second. One of the gotchas with I/O stat is that when these are very small numbers, you can get rounding errors. So if you only have 1 or 2 I/Os in a column, sorry, in a row, 1 or 2 reads and writes, ignore it. Okay, it's rounding errors, can't be trusted. We got more than 5 or 10, and you're getting somewhere. Megabytes read, megabytes written. Right, intentionally, I'll come back to here. This is the device that we're seeing, and this here, %B. Can somebody tell me what %B means?
Busy.
Busy.
Not idle.
Not idle. Well, yeah, sort of. Okay. Now, it is not the amount of I/O that disk can cope with. Okay. It is the amount of time that one or more commands, that's I/O packets, right, SCSI commands, are being dealt with by the disk. Okay. So you could, if you could have %B at 100% if the SCSI target driver, SD, SSD, sent a command, waited till it came back, immediately sent another one, and that there was no gap between them. So it's one or more I/Os are being processed by the disk, and that distinction is quite important. Just because it's 100% doesn't mean that that it doesn't have the potential to deal with more I/O. Okay? It may be the case, it may not. The potential. %W. So the target driver, SCSI target driver, SD, SSD, has a queue, typically up to 256. It has a second queue that you can't look at without kernel debugger, but if you're putting stuff on that second queue, you've got bigger problems. And the %W means basically that the SCSI target driver is queuing I/O but not sending it to the disk. Now, there can be 2 reasons for that. One is that when the SCSI target driver does its probe to the disk, it'll go and look in the comp file and says, you're type XYZ and you have a queue depth of 4. Therefore, I will only send 4 commands at any one time. And after that, I'll back off. And I'll wait until the number of outstanding commands to the drive drops. And I'll put them on this wait queue. Basically, if you're consistently seeing numbers in here, then your disks are probably saturated. Okay. Right, okay. Next column, significant, is the active service time. It's average service time. And this is the amount of the average time that I/Os take to go from the target driver at the bottom of the kernel out to the disk and back. Okay. Now this can be a little bit, you've got to take a little bit of care here, because it could be that you've got 99 I/Os completing really, really quickly, say in 1 millisecond, and 1 I/O taking 1 second, and that would give you 100 milliseconds. Okay. And what's a reasonable value in here? Depends on your storage, but I would say if you want to run a fast system, you'd be looking at under 10 milliseconds. When you're seeing hundreds of milliseconds, then that's glacial. When you're seeing that has a value of thousands, then it's over a second. So you can dig a little bit deeper than the dtrace, and I'll show you. I think I'll show you some of that. There's a D script in user demo dtrace io through dot, and you can use that to work out the distribution of latencies. But this is important, and this is really your guide to, are the disks busy? And again, this one here is the wait service time. So this is